I'm going to show you a way to divide called the scaffold algorithm, and you may not have ever seen this before. You may not have realized there was another way to divide besides long division, but it turns out that there is. So I like the scaffold algorithm because it's kind of like long division for people who aren't perfect. And I feel like that kind of fits all of us. So you just get to make a bunch of guesses. You don't have to divide perfectly at each step. You get to make a bunch of guesses, and then you just add up all your guesses at the end. And so what you're going to notice is we're going to get like a bunch of numbers stacked up. And when do you know what a scaffold is? If you can Google it if you don't know what a scaffold is. But when they're going to build a building or they're going to do brick or something on the outside of a building, they build these huge scaffolds for the people to climb on and walk on so that they can get on the side of the building. Anyway, that's kind of what this is going to look like. So I'm going to do two examples. We'll start with the smaller one, 726 divided by 6. So we set up like long division, like normal, right? This is our dividend, 726, 6 is the divisor. But instead of dividing place value by place value, like we're not going to divide into 7, we're not going to break it up, we're going to divide into the whole number. So you think, well, how many times does 6 go into 726? Go, I don't know, does it go in there 10 times? Does it go in there 100 times? And you want to pick nice numbers like 10s and 100s or 20s, things that you can do in your head, because the idea is it's supposed to make the math easy. Well, I know that 6 will go into 726 at least 100 times. So I'm going to put 100 because the math is easy. What is 100 times 6? 600. So let's see how close I was. Well, I was off by 126. So now I'm going to divide 6 into 126. Does it go in there 10 times? Sure. What's 10 times 6? That's 60. Well, that goes in there. Let's see how much more we have to go. You'd have to regroup. That'd be 66. Right? How many times does 6 go into 66? Well, it goes in there 10 times. I know it. I know that. 10 times 6, 60. We're only off by 6, and 6 goes into 6 once. And there we've gotten it all the way down to 0. And so what you do to get your final answer is you just take all these numbers and you add them together. And it should be easy to add. That's 121. So what is 726 divided by 6? It's 121. I don't know if you've ever seen this before. And right at the end, if you realize that 6 goes into 66 11 times, you could have put an 11 right there. You could have lumped those together as an 11. But the idea is just to make guesses. And you can make it take a long time, or maybe you can get it done relatively quickly. But you don't have to be perfect. That's what's nice about it. So you just get to make guesses. We'll try it again. And you'll see why long division is a little bit more efficient. So we're going to divide 24 into 3,640. And I'm not going to go place value by place value. I'm going to go by the whole amount all at once. So I know it'll go in there at least 100 times, right? 100 times 24 is 2,400. Let's see how much I have left here. 1,240. That's where I'm at. Okay, 1,240. How many times does 24 go into 1,240? Well, I know it doesn't go 100 times because that would be 2,400. Will it go in there 10 times? That'd be 240. Oh yeah, it goes in there 10 times. Oh, it might even go in there 20 times. Let's see, what would 20 times 24 be? Well, that'd be 480. So let's see, 20. I don't want to do 10 and then 10. I'll call it 20. 20 times 24 would be 480. And if we subtract, we should get 760 there when we subtract. So I can put another 20 in there, right? 24 will go in there 20 times. That's another 480. And then subtract, you'll get 280 when you subtract. Well, can I do another 20? No, because that's 480. I don't have quite that much. So maybe 10. Let me do 10 times. 10 times 24 is 240. I'm pretty close, right? I'm only off by 40 now. And 24 will go into 40. Will it go in there twice? Let's see. No, it only goes in there once. So 1 times 24 is 24. I think we're going to get a remainder on this one. 16. Now 24 is bigger than 16, so that's how we know we're done. So the way that you get the rest of the quotient, though, is you add all of these together. So 100, 20, 40, 51. So your final answer is 151. Don't forget about the remainder. Remainder of 16. All right, remainder 16 there. That's from that guy. So you just stack it up, right? You just stack up this little scaffold, and then you add up all your best guesses. Again, notice the numbers we're using here. We're not using weird numbers like 7 and 12 and 14. We're using ones and tens and 20s and hundreds. We're using numbers up here that make the math super simple. And it may take longer, but you don't have to use a calculator. And that's kind of the idea. Y'all know as teachers, you can't use calculators in the classroom, in elementary classrooms. So you got to be able to work these out. And so what'll happen is you'll have kids that are like, man, I don't want to do 20 and 20 and 10. Couldn't I have just done 50 and been done with it? And you're like, yes, you could. Let's do that instead. And then you start realizing you can use 50 instead, and then that's kind of a precursor to long division, because then you can say, well, if you want to be the most efficient, let's do long division. But this is just sort of an alternative method called the scaffold method that maybe you haven't seen.